Improper integral is very easy and little topic. This is not big topic. Finished, everybody? So improper integral, two types you have to find from finite integral. Finite integral means your lower limit, upper limit will be finite. That is called a finite integral. When limit will be infinite any one place, that is called an infinite integral. So on finite integral, if any one limit point, either A or B, are called infinite discontinuity point. Infinite discontinuity point means x tends to A or x tends to B, or both limit does not exist will come. Plus infinity, minus infinity, like that. So that is called the infinite discontinuity points. If infinite discontinuity points you are getting, then that is called the improper integral, otherwise proper integral. Proper integral only possibility for this, because whenever infinite integral will happen, infinite integrals are always improper integral. So proper integral means your limit will be A to B, finite integral, and no infinite discontinuity point. Okay. This is just a normal integration type. If question also asking your 11 class 12 type integration to finite value coming means convergent, infinite value coming means divergent. Okay, but theoretical more asking, theories we will see. Next we will see comparison test. That finished? No. Right. This don't write. That finished means tell. This. Finished this side. Same you write for B. This understood, no? What happening here? Fx means A is infinite discontinuity point. On that infinite discontinuity point, limit extends to A, fx by gx. Finite value will come. But what is g of x? G of x we have to choose from f of x, and choose means g of x will be the multiple function type. Because of g of x only, f of x fail going. Limit extends to A. And g of x also limit extends to A fail will go. Like that, g of x have to choose from f of x. After that, integration fx and integration gx convergent divergent to each other. So fx they are asking only, so we will verify g of x. If this is convergent, this is convergent. If this is divergent, this is divergent. Value different. Convergent value, integration value different. Same right for b. If b is infinite discontinuity point. Everybody breakfast and all complete have no? No. Want to do? Complete have. Okay. No, from morning direct came Complete him is no problem. Not complete means 5 minute break can give. 5 minutes. Not doing. Complete. 5 minutes break one. Okay. When 1 minute. This right first. This I will finish. Little only have. Just 2-3 questions. After that, 10 minutes break I will give. Not 5 minutes. Okay. Chandan sir giving no 10 minutes take break. Sir will start after 10 minutes. He used one dialogue. When limit will be infinite case, in that time limit extends to plus infinity minus infinity, whatever given have, and fx by g of x we have to choose. We have to do L finite value will come. What is g of x? G of x have to choose from fx, but that given function f of x we will convert in 1 by x function form. Means we will take common cancellation, full function will be 1 by x form. So whatever common portion will come, that only g of x. And at infinity this will exist. After that, same divergent convergent to each other. Same case. Suppose plus minus infinity to plus infinity given have. Then we have to partition have to do and both have to apply. Minus infinity to suppose 1, again 1 to infinity. Like that. And both have to apply. Another next. Maybe whatever they are giving, suppose 1 to infinite they give. And 1 is infinite discontinuity point. Then this also you have to apply for 1. But we have to do partition. 1 to infinite, 1 is infinite discontinuity point. So 1 to 2, 2 to infinite. So 1 to 2 case, you have to apply this, and 2 to infinite case, you have to apply this. That g of x choosing important. Here g of x is the multiple function of with f of x. But here g of x, we have to convert first 1 by x function, after that common portion. Here here fail will go. So limit changing, g of x will change. Okay. Next have Amuda what writing? Not finished. That. Integration 0 to 1, 1 by x into x minus 2. This is convergent divergent. So this type integration you did, 11 12 class, partial fraction and all applying. So you can solve it. Normally convergent divergent asking, so direct formula use and solve. Finite value coming means convergent, and infinite means divergent. But if theoretical, they will ask question, what is the infinite discontinuity point? What is g of x here? Integration g of x is convergent or not? Any theoretical, then by theories we first see this fx will be correct. So 0 is infinite discontinuity point. G of x, what we will choose? Because of 1 by x, this fx fail going. So 1 by x itself a g of x. And g of x also extends to 0, fail have to go. I wrote no, extends to 0, g of x also fail. Okay, and it out. X minus 2, 0 extends to 0, fail will go. Extends to 2, fail will go. But 2 not have no here. Okay, we have to choose. I will choose. Suppose I will do here 2. Then 2 also infinite discontinuity point. When both cases will come, then we have to do partition. Like that. And I solving now for this I1. Suppose I1 I am solving. So I1 solving means 0 infinite discontinuity point. So g of x will be 1 by x. I2 means 2 will be the infinite discontinuity point. Here g of x will be 1 by x minus 2. Okay. So g of x changeable, always will change. So suppose I1 I am solving. Finish after. G of x will cancel, then 1 by x minus 2. So minus 1 by 2. Finite value. So integration 0 fx dx and integration 0 to 1 g of x dx are convergent or divergent together. Fx they are asking only, so g of x we will find. So g of x dx, what will happen? Log x, log 0 minus infinity fell, divergent. So I1 is divergent. So 0 to 1 fx dx divergent. I2 suppose you are going to solve I2 1 to 2. And any one divergent is fail only. This is divergent only. Both will be convergent, then that is a convergent. Suppose I2 solving means same only. Here g of x will be 1 by x minus 2. Same limit. One by 2 will come. log 1 minus 1 value will come. So modulus using means 0 only, but 2 minus 2 minus infinity will come. Anyhow, plus infinity divergent only. So integration 1 to 2 f of x dx means I2 also divergent. So finally given integral 0 to 2 fx dx divergent. Okay, right.
Sir, sir,
Ah,
sir, log minus 1 is not defined, right?
log minus 1 non-defined, but modulus you can use and 0 you can use. Leave it.
Okay.
Otherwise, there you write modulus of x minus 2 if you want to write about log 1. Because negative side undefined, no.
Okay.
You can go fail this integral without mod. Convergent coming here. Here g of x convergent have, so integration fx dx means given integral is convergent. Understanding, no? G of x, how choosing? This question can try. Any problem? Huh? Oh. No, no. Infinite integral have means this is improper integral. Improper integral may or may not be convergent. You have to verify next, no? Infinite discontinuity point only possible for finite limit point. Here one is a finite limit point. So suppose here 0 to infinity here, then 0 will fail. So 0 is infinite discontinuity point. Then you have to change partition 0 to 1, 1 to infinity. And 0 to 1 case g of x will be 1 by x. But 1 to infinity g of x will be 1 by x square. Okay. Finished. G of x what? Oh. Wait. Means x power 5 by 2, correct? And x square have. Then what will happen? 5 by 2 minus 2. 1 by 2, correct. G of x will be 1 by root x, and x tends to infinity. G of x existing integration 0 to infinity. To root x, no, integration minus 1 by 2 plus 1, 1 by 2 only. Down also 1 by 2, 2 root x will have. So infinite divergent coming. This is divergent. So like that question only, no other anything. Suppose here in this question 0 to infinity, suppose they will give. Here say 0 to infinity. So 0 will fail, no, this fx. So 0 is infinite discontinuity point. So first you have to change finite limit both side. Because if 0 is an infinite discontinuity point, then g of x will be different. And 1 to infinite g of x is different. So you can change 0 to 1 and 1 to infinity like this. So 1 to infinity here solving g of x is 1 by x square.